Hello. Good afternoon. Thank you all for finding time for today's A Day with a Scientist webinar. My name is Ferdinand Perillo, or just call me Ferds. I'm a Special Science Teacher 1 at Philippine Science High School, Ilocos Region Campus, this campus. A very warm welcome to all. It's a wonderful day and I feel privileged to extend my warm welcome to all presented here. To give us a rationale, it has been a tradition of our institution to invite experts from the scientific community to serve as a resource speaker in our A Day with a Scientist, where experts, scientists, and research specialists in the field of science and technology are invited to speak or lecture before our scholars every month for a day. We believe that this event will not only stir the curiosity of our scholars to do scientific research and be aware of the applications of arts, design, and technology in the applied sciences and engineering, but will also essentially define their direction for the years to come in Pisay, Ilocos, and beyond. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the chat box or in the comment section. I'll bring them up during the presentation if necessary, or we will also have time for questions at the end. To keep the quality of sound functional during the meeting, please mute yourself when you are not sharing. The technical administrator, Sir John B, may also mute the room if necessary. But please remember to unmute when you wish to share. Now, without further ado, let's have the prayer prepared by Chiro Madriaga, grade 7 scholar, followed by the national anthem.
Let's bow down our heads and feel the presence of the Lord. Father God, thank you for this day you've given to us. We ask your mercy and overflowing protection. Bless us today as we go on in this activity. Bless and guide our teachers, staff, and our classmates. Bless the schoolwork of our hands. We ask also your forgiveness for all the wrongdoings. Touch our hearts, our minds, Father God, and remind us of your love. We lift up this day to you, that may this program will be successful and informative, and we will bring out all the glory into your name. All this we ask in Jesus' name, through the intercession of Mama Mary. Amen.
Thank you, Chiro and Sir Gandhi. Now, to formally start, may I call on our ever-supportive director, Dr. Ranali N. Ortesa, to give her opening remark. Over to you, ma'am.
Afternoon. Thank you very much. Thank you very much, Ferds. And to the rest of the technology unit, thank you very much for organizing this event, A Day with the Scientist, with Professor Fortunato Dela Peña Jr. as our speaker. So good afternoon, my dear scholars. So I would like to welcome each one of you to this A Day with the Scientist. This afternoon, you will be able to appreciate the value of innovation and the value of design thinking. Through Mr. De La Peña's lecture, you will be able to see how arts and design marries with science and technology innovation. So my dear scholars, I hope after this session, you will be able to appreciate that being our future scientists, mathematicians, and engineers, you should have that value of innovation, you should have that value of imagination, that from time to time you will come and think about solutions of this world. And hopefully, if you will also be part of this public sector or even in the private sector after your graduation, we'll be very proud now to claim that a scientist or a technologist or engineer, a graduate of Philippine Science High School, made a good invention. So to Mr. De La Peña, on behalf of the whole Ilocos Region Campus faculty and staff, thank you very much for accepting this occasion, this A Day with the Scientist, despite your busy schedule. Again, to everyone, welcome and good afternoon.
May I now request Sir Lucas, Special Science Teacher 4 of this campus, to introduce our speaker of today, Sir Fortunato B. De La Peña Jr., to our esteemed scholars. Over to you, sir.
Thank you very much, Ferdinand. Sir, can I share my screen? Thank you. Okay, our resource speaker, well, it is an honor to introduce our friend and also our colleague in the Fab Lab industry or in the Fab Lab sector. So our resource speaker is an associate professor of the University of the Philippines, Diliman, and a faculty coordinator of the UP College of Fine Arts Fabrication Laboratory, or FabLab. He is a graduate of the following degrees: Bachelor of Fine Arts, major in Industrial Design with honors at University of the Philippines, Diliman, and Master of Industrial Design at National Yunlin University of Science and Technology, based in Taiwan. Some of his professional accomplishments are: one, being the co-proponent and current head of the University of the Philippines College of Fine Arts Fab Lab, the first Fab Lab in UP Diliman that provides a maker space and access to prototyping and equipment for students, faculty, makers, and enterprises. It has served more than 3,000 clients since it opened last December 2016. Second, being the co-founder and design director of Humanitarian Engineering, Entrepreneurship and Design, or HEED, a research group based in the University of the Philippines that aims to serve the underserved through technology and design. Furthermore, he is also being awarded with 22, wow, sana all, industrial design patents for flat pack furniture designs and UP Professorial Chair, Tito De Santos Professorial Chair. He has experience and expertise in the following areas: product display and exhibit design, user and product research, computer-aided industrial design, high-end digital rendering, package graphics, product design, biomass gasification technology, furniture design, bamboo furniture, and computer-aided manufacturing. Help me welcome our resource speaker and guest scientist for today, Mr. Fortunato Tito B. De La Peña Jr. Pass to you, sir.
Hello, good afternoon, everyone. Thanks so much, Sir Mark Lucas, for the lengthy introduction. Parang dinagdagan mo yata yung, yung nakasulat sa sa CV ko. Good afternoon, Dr. Orteza and Engineer Perillo. And I would like to thank Sir Bis for also inviting me and for arranging everything. Good afternoon, scholars. This is actually an honor for me because I know only scientists are invited to speak in these events, and I'm really guessing that this is the first time that a fine arts graduate will be talking in front of you. I'm not sure. To the faculty, don't worry. I won't sway them. I won't convince your students to drop everything and shift to the creative arts. Although I must apologize in advance if ever they decide to. Just kidding. Okay, although the industrial design program is under the College of Fine Arts, the study of it is not limited to artistic expression and aesthetics. Actually, through this talk, I'm hoping that I'll be able to communicate to you that research and science are two of the most important fields that is involved in designing products, especially when it comes to engineering and psychology. Both plays a big role in what we do. So again, I'm not here to talk you into getting into UP industrial design. I don't think that's possible because we're under. I mean, the industrial design program has a Bachelor of Fine Arts degree. So I think since you are a PSI scholar, you need a Bachelor of Science course or degree. But let me widen your options. You don't have to take this course. But on the other hand, if you're the type who likes to imagine and create, I think industrial design is one of the fields that you may want to look at. And there are a lot of universities that offer this as a Bachelor of Science course. So I thought that I can make the first few minutes interesting for you by mentioning some of the few prominent names in the field of design. And most of them, or some of them have, a lot of them actually have science backgrounds. And most of them have a background in industrial design. Next slide, please. So the first person that I'd like to introduce to you his name is Donald Norman. Donald Norman's books are like a Bible to us designers. He is a psychologist, but he also finished electrical engineering in MIT. I'm sure familiar kayo sa Apple products, right? Donald Norman worked as the vice president for Apple's Advanced Technology Group, and I consider him as the father of what we call usability engineering. He basically invented that it measures how user-friendly a product is. It is also closely related to the study of human factors. When you say human factors, it is a study. It's a science where you take into account bodily measurements called anthropometric data, and the cognitive capabilities of humans, no, in relation to, let's say, the workplace or how products are being used. He's one of the pioneers of what we call user-centered design, and both of those terms, human factors and user-centered design, play a crucial role in designing products, specifically dealing with the user experience. Donald Norman is one of the architects behind the user interface of, I'm sure you're familiar with iPhone, iPad, etc., etc. And I think the user interface design of Apple products is one of the reasons why people buy it. No? It's simply because they're very easy to use, and it always gives a somewhat pleasant experience. Although I must admit that I'm not an Apple user. Medyo expensive din kasi siya. Next slide, please. The next person is Joni Ive, or Jonathan Ive. Joni Ive is, I think he's British. He's an industrial designer by background and profession, and he was the chief design officer of Apple. Joni and Donald, the guy I mentioned previously, together with Steve Jobs. I'm not sure if you're kung inabutan niyo si Steve Jobs. No? Together with Steve Jobs, they played a big role in changing the image of Apple when they came out with pioneering products a few decades ago. No? It started with the first iPhone, I think the iPod, and then iPhone, and then the iPad. Although they weren't the first, their touchscreen technology was miles ahead from the competition. And it, like what I mentioned, it was combined with a very user-friendly interface. Next slide, please. The last person that I'd like to introduce, I guess to bring it closer to home, is Winnie Camacho. Winnie Camacho is a graduate of UST. He studied industrial design, and she took higher studies in the Art Center in California, if I'm not mistaken. Personally, I felt so proud to be an industrial designer when I learned that a Filipino was in charge of the design of Mercedes-Benz. No, Winnie Camacho is sorry. Winnie Camacho is the one responsible for the designs of Mercedes-Benz during I think a few years ago when the C-Class came out. That's the car on the bottom right, and the X-Class, the pickup truck on top. No? And he visited the Philippines a few years ago, although I wasn't able to visit his talk. I mean, for me, it was really cool because imagine those companies only hire the top 20 or 30% from the top schools, and Winnie Camacho is on top of that company. I mean, he's the one designing for a German company. I mean, I was really impressed. So anyway, next slide, please. I didn't plan on including those slides actually. I just wanted to get your attention because I'll be throwing a lot of information to you in the upcoming slides. And for better understanding and appreciation of the field of industrial design, I want to start off, of course, by introducing myself properly as your resource person. This is actually the flow. It's going to be the flow of my presentation. Um, I would like to share to you what was in my head before I chose to study this, and where I am now, and probably what I plan to do next. Next is the history of industrial design. In any introductory topic, I think explaining how it came to existence or explaining its existence is quite important, especially if we are going to dive deeper into it. But not so much. Normally, when I teach the history of industrial design, it takes almost half of the semester to accomplish this. So I mean, there's so much to learn about this, and one afternoon is not enough. After which, I'll be glossing over why we have different eras of design. I mean, I'm referring to a given time period where, let's say, all products look the same until such time that you start noticing that the styles or the designs of products are changing. So, kumbaga, if you take notice of the products that came out 10 years ago when you were much younger, if you still remember that, as compared to how the products look at present or look right now, you will notice probably a few nuances or differences. So I plan on tackling the reason behind that. I mean, let's look at the reasons why these things happen. And the next key aspect in understanding what industrial design is by getting an overview of the whole product development process. After which, I will discuss everything, how on the perspective of product development teams, no? How do they decide to start developing a product? I think after discussing those things, only then will I be properly give you a definition of what industrial design is. I'm taking it slowly because I want to build that context to you. I structured it this way, so hopefully, yun nga, when I begin to throw out definitions, you'll have a good grasp of what it is. Then, my last topic will be about the idea of designing and manufacturing on your own. So next slide, please. Next slide, please. Okay. All right. So let me get right into it. When I was in high school, I had that inkling of what I wanted to do in the future, but I never knew about. I mean, I knew what I wanted to do, but I did not know what I needed to study to know how to do that. Okay. I never thought of researching the things that I needed to know for me to know what I want to study. I was choosing between architecture and industrial design. And the sole reason for thinking about those two was because I like sketching, and I liked imagining things and translating them into, I don't know, I was sketching shoes, or I was sketching cars, something like that. But I never really took time to dive deep into what industrial design is, or what, I mean, architecture is pretty much, I mean, you can find samples of architecture wherever you are, when you look around. It's also the same with industrial design. The products around you are, almost all of it are designed by industrial designers or product designers. So when I started studying, I felt that I was wrong because it was more than drawing and sketching. It was way beyond that. It was far more interesting than that. So after I graduated industrial design, My first work was with San Miguel Packaging Corporation. Next slide, please. Yes, sorry. This is where I learned about the technicalities and packaging mandatories, etc. But then somehow I felt that I wanted to go back in designing products, and I wanted to learn more about design itself. So I decided to take my master's in Taiwan. Why Taiwan? Because number one, for practical reasons, they were offering scholarships at that time. And number two, I knew that almost everything gets made in Taiwan, if not China. Even, I mean, some of the factories in China are owned by Taiwanese companies. So I thought the industrial design industry must be flourishing there, and it must be something. So, I mean, I was right. I think I came to the right place. I studied lifestyle research and computer-aided industrial design. So, because I wanted to know more about researching on what to design. So I wanted to know how to do design research. And apart from that, I wanted to learn the skill in turning these ideas into tangible concepts. So aside from studying lifestyle research, I also took computer-aided industrial design in Taiwan. Can we go back to the previous slide? Yes. So I worked in Taiwan for 1 year, and I worked for a renewable energy company where initially I was designing components for the mini power plant that they were selling. But I didn't include samples of that in my presentation because there were components, so there's nothing to see. But later, my boss transferred me to work on the business development side of the company. So I was shipped to Cambodia to help set up their business, their renewable energy business. And I think after a year, I decided to go back in the Philippines, where I started to work with the Design Center of the Philippines. Design Center of the Philippines is an agency under the Department of Trade and Industry. I started with consulting projects until I was able to head their product innovation program. Back then, we had a team of 21 designers, and we tackled various product development projects from bamboo to food processing technology. So the photos that you can see are some of the work that I've done before with Design Center. And actually, the two images on top are in collaboration with DOST, TAPI, Technology Applications and Promotions Institute. Next slide, please. Next slide, please. Yeah. While I was working with DCP, I started teaching part-time with UP until such time that I was given more subjects to teach and I was hired full-time. So I started with teaching visual perception. So those are the core fine arts courses. I started to teach materials exploration. Those are the things that the photos on the slide are some of the things that I ask my students to do. So we explore different materials. We explore finishes. I teach them how to make product prototypes or mock-ups. You can see two samples of their work. These are tape dispensers. So they hand fabricated these tape dispensers out of composite material. Next slide, please. It was also in UP that I met the founder of humanitarian engineering, entrepreneurship, and design, si Professor Jill Manapat. She's the one on the top right photo, yung nakatayo sa table. So she's a professor. She's a professor in materials engineering, and together with two other faculties, professors in different departments in UP, different units. So we founded HEED, or Humanitarian Engineering, Entrepreneurship, and Design. So basically, it's a research group composed of engineers, community workers, and designers, all working together to serve the needs of what we call the underserved. So an example would be Project Plastikan. It's essentially our objective for that project is to empower a group of women in Malabon by teaching them how to make products out of plastic waste. So the photo where Professor Jill is, so yung nakatayo siya, that's a plastic injection machine, manual plastic injection machine that we fabricated in the Fab Lab based on the open design of preciousplastic.org. So hindi kami yung nag-design nun. We just followed their plans and made one. We made a set of plastics recycling machines. Tapos the one on yung nasa top left, the one with the hexagonal tile, that's made of shredded plastic. So we injection molded it to come up with a prototype of a coaster. Yeah. And like what Sir Mark mentioned, I'm also the coordinator and manager of the UPCFA Fab Lab. Together with Sir Mark Lucas, we are part of, soon to be part of, I think, Fab Labs PH. So although even before, we have an established network of friends in the Fab Lab community. Okay, next slide, please. I still do side projects, so mga racket on the side. One example is this: I designed for an electronics company based on Singapore, and their manufacturing is in China. Next slide, please. I also work with friends in the advertising industry. I help them visualize usually yung stage or yung set for commercials. Next slide, please. Ayan, so enough of the boring stuff. Let's go to the interesting part. So next slide, please. So to talk about the history of industrial design, I think I need to rewind a couple of centuries back to the time when products were made by hand. Okay. During that time, people were, of course, thinking ways of how to speed up the process of making or producing. Kasi kapag gawang kamay, if it's manual labor, it's really time-consuming. So one idea was to divide the production process into teams. Kunwari, one team will be in charge of cutting the wood. One team will be in charge of painting, etc., etc. So they divided the labor. So the idea of division of labor was, kumbaga, trying to make the process or the production more efficient. This was during the absence of machinery pa. So the idea here is that one person will only do one thing all day. So the idea of repetitive action leads to mastery. And when you master something, I guess by muscle memory, you tend to do it faster. So in essence, you're trying to, para kang gagawin mong machine yung isang tao, parang ganun yung idea nila. It doesn't sound correct, but excuse me, can I take this phone call? Sorry about that. Okay, so the division of labor, they say, gave rise to the Industrial Revolution. And this is where the idea of industrial design began. Next slide, please. The next slide, please. Hello? Am I back? Ayan, okay. Sorry, can you go back again? So, goods that had once been painstakingly crafted by hand, so before the Industrial Revolution, no, they started to be produced in mass quantities by machines in factories, all thanks to the introduction of the steam engine. So, I'm sure you're familiar with the steam engine. So, si Thomas Newcomen yata yung nag-invento nun, and then James Watt improved it, no? Or was it vice versa? Yeah, I think James Watt improved the steam engine. So that meant that the goods in factories were produced much faster. It was, the products were being produced at a faster pace. And that also meant that goods needed to conform according to how these machines work. So for efficiency, you know, especially for efficiency. So next slide, please. So here's an example. These are microscopes from almost the same time periods. The one on the left, yung medyo intricate, yung parang may mga maliliit na statua. That's what they call a Renaissance aesthetic. No? Pag sinabing aesthetic, yun yung parang look niya, yung design niya, yung feel. No? And the one on the right is what they call a vernacular design. So, pag sinabing vernacular design, it's simple, it's utilitarian, it focuses on the function. But most of all, it's really because it's easier to produce than its counterpart on the left. No? So on the onset, during that time, no, the vernacular design become popular because mas madali siyang gawin. No? Factories were aiming to make more products so they can sell more products so they can earn more. Thus, they were going for something that's easier to produce. Next slide, please. So, one guy from Germany during that time named Peter Behrens, hindi ko na nilagay yung picture niya. He's an architect and he was hired by this company called AEG. It's one of the oldest companies in Germany. Okay, Peter, we're hiring you to be in charge of the aesthetics of everything in our company. So yung sabi nila kay Peter. So, sabi naman ni Peter, okay, I will design everything from the building to the graphics to the logo hanggang dun sa product. I will make everything consistent. Sabi niya, I will create an identity system for AEG. In doing so, sabi niya, I want our product to be easily recognizable. Kapag nakita ka ng electric fan, malalaman mo na agad, without seeing the logo, oh, this is a product made by this company. Parang ganun yung objective ni Peter Behrens. And Peter Behrens, I actually consider him as the father of industrial design. So, because that's the idea of what industrial design is. Parang ganun. So when Peter Behrens started doing this, it signaled the start of an era. And that era will eventually transition into other eras of design. Yeah. So next slide, please. Next slide, please. Now, like what I mentioned before or kanina, no, you will notice observable differences sa mga products kada taon. Nagbabago yan ng color, ng shape, ng size, ng function, whatever, no? That's because each design era, itawag nating design era, it follows what you call a certain design paradigm. Pag sinabing paradigm, no, we can say that each period follows a certain set of ideas that people follow during that period. I mean, it holds true during that time. No? So ano ba yung mga factors na yun? Kunyari, in terms of art, mahilig yung mga tao sa ganitong kulay or ganitong pattern nung time na yon, no? Pwede na influence siya by fashion, no? Pwedeng influence siya by culture at consumer preferences. And most of all, it's a big factor in influencing of how products look is technology. Excuse me. Okay. Now, one notable design era, next slide, please, is called Bauhaus. I needed to focus on this era because up to now, yung set of design paradigms niya is still very, very much relevant. Bauhaus was a school in Germany, and it was founded by, andyan sa slide, no, by Walter Gropius. And ang objective ni Bauhaus School was to train a new breed of architects and artisans that will uphold or reconcile principles of mass production technology with, I think important, with artistic vision. Okay? So, andun din yung idea na while you are reconciling all of these factors together, kailangan hindi pa rin mawala yung form and function. Parang gano'n. So, form and function yung isa sa mga emphasis ng Bauhaus movement. And up till now, that is still very much relevant. If, I think, si Joni Ive, yung designer na mention ko kanina, he follows the same principles, no? Form and function. Now, si Peter Behrens, like what I said, was key in transitioning everything into the Bauhaus paradigm. Okay. Next slide, please. A good example of how technology is a big factor in influencing design is the invention of Tupperware. I'm not sure if kids nowadays are familiar with Tupperware, but I'm sure sila Dr. Orteza, sila Engineer Perillo, sila Sir Mark, alam ko ano yung Tupperware. No? Anyway, on the photo on the left, yung may kalbo, that man is Earl Tupper, and he invented Tupperware. Earl was working in an oil refinery when his supervisor gave him yung tawag doon slags, no? So sa process kasi ng oil refining, meron siyang byproduct. It's called slags, no? So Earl took that material, took that byproduct and transformed it into plastic containers, no? So he found a way of transforming this into a sellable product, no? So the photo on the right, ito yung, and that is how they marketed it, no? Makikita niyo yung photos dun sa right. Ang tawag dyan ay Tupperware party. So, because during that time, I think this is post-war, naghahanap ng income opportunities yung mga housewife. And this direct selling was one of the promising forms of livelihood back then. So, nag-organize sila ng parties. Pero ano pala yung parties, no? It's also a venue for them to sell the product, no? And I think it's a very effective way of proving how that product will function, no? And so, after the invention of Tupperware, it really changed the landscape of how products were made. Prior to that, products were made mostly of a material called melamine. It's a different type of plastic. I think it's a term. I'm not sure if it's a thermoplastic, no, but it can also be molded into shape. But polypropylene was a different animal, kumbaga. Mas matibay kasi yung polypropylene. Dun gawa yung Tupperware. Next slide, please. Now, how did this affect design? No? Ito yung question. Since plastic was made through the process of injection molding, no? So ang ibig sabihin ng injection molding, there are pellets of plastic, and then you gather them, and then you put them in a machine. That machine will melt it. So once they melt, magiging ano na siya, parang liquid na yung plastic, natutunaw na siya. And then the machine will inject it into a mold. No? So kapag sinabing mold, that is, I don't know if familiar kayo sa ice tray. No? Yung ice tray kasi, that's a good example of a mold. No? Depending on the shape of the ice tray, ganun lalabas yung yellow. So ganun yung, I mean, very crude example of a mold. No? So the melted plastic will enter a mold. Tapos it will harden almost in an instant. Mabilis, no? So it changed everything because now, I mean, after the introduction of that material, it meant that almost every shape and every color is possible to make. All thanks to the research and development, of course. No? So that's how important R&D is. No? Itong mga nasa pictures ng presentation, samples lang yan of how products look through different eras. No? So, noong 1940s, they started making toys out of plastic. No? Before, they were making toys out of metal and wood. Noong 1960s but 50s, they were already making chairs na very complex yung ano niya, no? Yung form niya. Noong 1990s, I'm sure hindi pa kayo pinapanganak noon. Ang uso naman noon ay yung black plastic, that kind of aesthetic, no? And up to the late 90s, up to the year 2000, hindi pa kayo pinapanganak noon, no? Nauso naman yung candy plastic. So it changes depending on, like what I said, the technology available and the preferences of people. Okay, next slide, please. So I hope by now you already have the context of how industrial design came about. I think it's time for me to elaborate on the product development process itself. No, this is the table. I mean, the image on your screen somehow represents how industrial designers work on every project. Excuse me. Product development timelines vary depending on scale and complexity. No, some product development projects can be completed within 3 to 4 months. Napakabilis na nun. And some may take 1 to 2 years or even 5 years or even longer. Example, the timeline is different when you say you want to design a mouse versus when you want to design a plane. No? The complexity varies, no? Depending on the scale of the project. Now, it is composed, the whole product development process is composed of several steps, and each step in itself follows a certain process. No? So, ano kasi siya yung product development process, it's cyclic. No? Meaning, medyo umiikot din yan. No? Hindi ko na dito sinama we have this term called the product life cycle. No? So, kung saan sinusundan naman yung parang life ng isang product, no? How it begins, saan siya dinadala, saan siya ginagamit, saan na siya dadalhin kapag nasira na siya, etc., etc. That's different. No? This is just focused on how a product development project starts and how it finishes. When you say finishes, when it's ready for production. No? So it starts with research, concept development. These are the major phases, no? Product architecture, prototype testing, and production, engineering for production. No? I mean production ramp up. Siguro dun sa whole process, I will just kumbaga detail the concept development process. No? Kasi it is one of the most important, if not the most important part of the whole product development process. But I think the tools used here are something that you can also use in your own, let's say, projects. No, I mean the research tools. So in the concept development phase, no, this process requires the product development team to, next slide please, to clearly define and articulate, number one, ano ba yung concept narrative? Kapag sinabing narrative, ano ba, what is the story of your product? I mean, what is your product trying to tell us? No? Ano ba siya? And number two is pinaka-important dito ay para kanino ba yung product? Who the product is for? Who are you designing for? The user. No? So, like what I said, there are several research tools that can be used in this phase. And this is actually a buzzword, yung design thinking. No? Kasi medyo for the past decade, it has really gained popularity, not just for design product development projects, but for almost anything. No? You can use the design thinking process. No? Now, you can apply the design thinking process dun sa conceptualization phase ng isang product development project. No? Okay. Like what I said, the whole process is time consuming as each step is a process itself. And one of the promises that design thinking is making is that the whole process of conceptualization, you can accelerate it. No? How are you going to accelerate it? Because it focuses on generating as much ideas as you can from more than one person, usually from a collaborative group of people, usually from a team yan. So the design thinking process is composed of, number one, empathizing. Pag sinabing empathizing, you're trying to put yourself in the shoes of the one you're designing for. For example, you're a designer and I'm designing for, let's say I'm designing for, ano ba maganda example? Let's say I'm designing for the elderly. No? So I need to put myself in their shoes. And by doing so, somehow I need to, kumbaga, live a day. How do elderly people go through each day? No? So parang I'll try to imagine that. I'll try to empathize with that. No? So from empathizing, it is the key step in defining what the problem is. And when you're able to define what the problem is, no, you already clearly articulated what the problem is. You will be able to create ideas that will, or generate ideas that will solve that problem. So yung ideation phase naman dito sa design thinking process, hindi siya reliant on one person. Usually kasi the design thinking activity is done by a group of people. And that puts a lot of advantage sa ganyang style kasi design thinking is what they call very inclusive. Pag sinabing very inclusive, very welcoming siya sa ideas ng lahat ng members ng team. No? You always apply constructive criticism. You don't say na, hindi maganda yung idea mo. You need to hear what the merits of that idea is. No? And you just list it down. So, after the ideation phase, meron na kayong set of ideas. From the set of ideas, you select the best one or you select the top ideas and you can combine them. So, pwede mo siyang i-combine. And then you try to prototype it. Kapag sinabing prototype, you try to embody it. Pag sinabing you try to embody it, you try to create a model ng idea. No? Using tinatawag dyan rough prototyping. You can use clay, you can use styrofoam, you can use popsicle sticks. No, it doesn't have to. It doesn't have to get the right aesthetic, but it only has to represent kung ano yung concept. Parang ganun. So that when you prototype it, you're able to test it, which is the last part of the design thinking process. Ayan. So next slide, please. And actually, this is a photo of a design thinking exercise workshop I conducted before together with Professor Jill sa Baguio. Now, dito lang, I just want to take note that before jumping into concepts, one of the advantages of design thinking is that it puts importance on what you call the user-centered design. Kapag sinabing user-centered, ilalagay mo yung user sa center, no? And you try to base your assumptions according to how the user will react to it or how the user will feel towards it. No? You'll be able to empathize with the persona that you're designing for, and you will be able to articulate yung problem. No? Ito yung I think one of the magandang outputs ng design thinking. Next slide, please. So once the narrative has been clearly defined, no? So you know who you're designing for, you have clearly articulated your problem, no, through the use of different design yung design thinking, no? Knowing the people you're designing for and understanding the context, it lays a good foundation, and it ultimately minimizes the possibility of moving forward with unsupported decisions, and it builds a solid design narrative. Next slide, please. So this is just an example, a quick example of a design case that used design thinking as a tool for conceptualization. No? There's a company called IDEO. It's spelled as IDEO. IDEO. It's like a research company, but it's a design company based in the US. And this is one of their clients, yung Shimano bikes, no? They use design thinking kasi Shimano was their client, and Shimano wanted to identify, to articulate anong klaseng bike yung pwede nilang gawin. I mean, there are so many types of bicycles out there that they don't want to just create, no? They don't want a hit and miss approach. No? So they hired IDEO, and then IDEO employed a design thinking process for this. No? Ito yung approach nila. So anyway, they were able to discover that a big part of the US population wanted to ride bicycles, but they weren't the type na they're riding because they want to ride bicycles for fitness. It turns out in their research that there's a big market for people who want to ride bikes just because they tawag dito, they feel some kind of nostalgia when they ride the bike. Pag sinabing nostalgia, parang naaalala mo yung mga good memories from the past, parang ganun. No? So they feel they get this some kind of nostalgic feeling from riding a bicycle, and that's what Shimano wanted to capture. So they designed a bicycle that's very easy for you to get in, madali siyang sakyan, and it's very easy to pedal. Meron siyang parang coasting feature na mag-freewheeling ka lang, tapos mag-enjoy lang kayo ng friends mo. And this bike was successful thanks to design thinking. Yeah, next slide, please. I'm just showing you some photos of kumbaga ito na yung trabaho ng designer, no? So once you have this idea, it's your job to embody it or translate the ideas into concepts, no? So you have to know how to sketch, no? Kung gusto mo maging industrial product designer. Yung sketching naman, it's something that you learn, no, through practice. No? Marami akong students na hindi talaga magaling mag-sketch and magkulay sa simula. But through practice, you get better at it. No? So usually designers start with this is what we call thumbnail sketches. No? I know someone who works for Panasonic here in the Philippines, and Panasonic, they manufacture, I think, the washing machines and mostly washing machines yata, the air conditioners, if I'm not mistaken, dito sa Philippines, no. They also have a design team here, no? Meron silang design department, no? And when I took my students to the Panasonic plant, no, my colleague who's working there told me that, here in Panasonic, when our supervisor asks for concepts, they ask us for a minimum of 50 sketches, no, and we need to produce that within a few hours. So sabi ko, wow, sobrang bilis pala ng process nyo, no? And after that, no, I've been asking my students to produce double that amount, no? 100 sketches per one of their projects, no? Anyway, next slide, please. After capturing the essence of the product, after sketching, no, you are now ready to prototype it. When you say prototype it, you make a model, a representation of that concept, a tangible representation. This is where I think yung advancements in rapid prototyping comes in, and I think you all have access to that sa Fab Lab. No? That's the beauty of Fab Labs. No? You are now able to, not really instantly, kasi matagal ang 3D printing if you're familiar with it. But as compared to before, during my time when I was studying, that was not possible. You have to do everything by hand, scratch build everything. Now, the goal of making a detailed prototype in product design is actually testing it, getting a feel of the product. You get the feel of its texture, its size, how it fits on your hand, how yung mga ergonomic factors niya, no? You need to evaluate it and you need to somehow validate your assumptions, no, when you made the design, no. Tama ba na ganito yung ginawa mong design, no? And you will know that by showing it to the people that you are designing for. You need to get their feedback, no. Yeah, next slide please. After detailing the design, I mean after prototyping it, and once you have gotten the insights of the user and you have revised the design, it is now time for executing the product architecture. This is a tricky, not tricky, but a very technical aspect na of the product development process, because you need to, if you're the design, we usually call the people in charge of the product architecture as design engineers, no? When I studied in Taiwan, a lot of my classmates, batchmates in Taiwan are now design engineers, no? So they're in charge of putting everything together, no? So the electrical engineer will give them the size of the components. The mechanical engineer will give them the mechanism, the exact details, and then the design engineer will put everything together, no? Now, usually, merong ginagamit na software to do that, wherein cloud-based na siya when the electrical engineer does the 3D model of the electrical component. Isa-save niya yun, tapos automatic na yun magre-reflect sa project file nung design engineer, no? Hindi na nila, it eliminates it makes the communication faster, no? Mas napapabilis yung product development, no? Dito rin, you need to determine how each part will fit. Do you decide for snap fit mechanisms, or do you decide to use hardware screws to fasten these components, etc., etc.? So, excuse me, this is a very time-consuming process na to, part na to ng product development. Dun sa pinakita ko example of headphones and microphones, I was just the aesthetic designer. So once I'm done with it, I send my 3D files to an electrical engineer who's also based here in Manila. And then he's the one to edit the 3D file. Tapos siya na yung naglalagay ng electrical components sa loob. And then he sends it back to Singapore. And then Singapore will send it to China for prototyping. Next slide, please. This is also part of the process, no? Before companies go on into manufacturing the new design, usually hindi muna sila gagastos for the expensive tooling cost, no? Kasi when you say soft tooling, there are two types of tooling, no? So soft tooling and hard tooling. So yung soft tooling, usually the parts, the engineering team will make a mold using silicone to mock up or to prototype the actual parts. And usually, yung resulting prototype dito is called the alpha prototype. That's the first first instance or first copy of the actual thing, no? Andun na lahat ng features niya. It looks, it feels like the real thing. It weighs like the real thing, but the process of making it is different pa. No? So they are still using soft tooling, and then when everything gets finalized, that's when they decide to invest on hard tooling. So medyo mahaba yung process, no. But they do it step by step, so um, they minimize yung waste, no? Especially sa resources. No? You don't want to be spending on hard tooling kasi it very expensive ang production ramp up, no. You need to be certain that everything is final before you invest on the hard tooling. Next slide, please. Now, nabigay ko na I already gave the overview of the whole product development process, but again, the question is, where does it start? No? How do companies decide on making a new product? Yun yung question. No? So there are two directions where product development projects start. No? One is called technology push, and the other one is called market pull. So tandaan nyo lang yung dalawa lang yun. Technology push and market pull. Next slide, please. So a good example of technology push products is that the direction of creating a new product comes from what you call R&D or research and development. So dito kayo mga future scientists, no? Nandito kayo yung may pinaka-important role dito, no? Kasi you will be the ones developing the new technology. No? So you develop a new technology, and then designers and design engineers and product developers, psychologists will form a team, market researchers will form a team and conceptualize, okay, what can we do with this technology? You will push the technology to the market. No? This is a new and innovative technology, and you are assuming that the people will embrace this. No? This is an example. No, this is called the Palm Pilot. They were the first ones to introduce touchscreen. I mean the handheld touchscreen, but it became popular, but they did not innovate. No? So namatay yung Palm Pilot sa market. No? And then Apple came out with the iPhone. Their touchscreen phone, which much better than the other touchscreen products noong time na yun. It revolutionized the way people communicate. No? Nawala na yung mga phones na may dial pad. No? Nawala na siya completely. No? It was very innovative at that time. So this is an example of a technology push product. So you have this technology, and then you think of product applications. Okay. Next slide, please. Kapag sinabi naman, when you say market pull, you base the design of a product based on what the market is looking for. Okay. So I'll start with the example of the car on the right. Recently, oil prices have been getting more expensive. People are looking for a more economical means of transport. And I mean, you can buy motorcycles, but what if I think there's a big market for starting families, no? So recently they have been coming out with smaller and smaller cars, no, that is boasting of fuel economy and affordability, no, because there's a big market for it. Okay. Another good example are fitness watches. People, yung lifestyle kasi ng people, they're getting more health conscious. And this is one of those what you call trends that I mean they already have the technology to it. They just need to change. I mean, there's existing na kasi yung watches so they just need to apply the right technology to cater to that big demand in changing lifestyles. No, this is also the same with front-facing cameras. Front-facing cameras are there because people like taking selfies. No? And some phone makers are taking it to the extreme by putting high resolution cameras in front. No? So I hope it's quite clear kung ano yung technology push and market pull. No? So yun. I think on both cases, ang laki ng role ng scientists and engineers dyan kasi they make everything possible. Next slide, please. Okay, now I think I'm ready to define what industrial design is. Let's start with the definition before. No? Before, when I say before, let's say during the onset of this, no? During the time of Raymond Loewy, which is, sorry, I wasn't able to introduce Raymond Loewy, but Raymond Loewy is the father of industrial design in America. Yeah. Siya yung parang kino-consider nila na father of industrial design. During that time, and during the time of the Bauhaus movement, I think the definition of what industrial design is the process of developing products that takes into account the principles of mass production, consumer demands, and artistic vision. So, kumbaga, they need to be able to catch the attention of the market through the aesthetics and the function. I mean, mostly on the aesthetics. Ang laki ng value ng aesthetics before. But now, next slide, please. It's evolving. It has evolved into something much more than that. No? Let me just read the definition of ICSD. No? So, ito yung International Society of Design. At its heart, industrial design provides a more optimistic way of looking at the future by reframing problems as opportunities. It links innovation, technology, research, business, and customers to provide new value and competitive advantage across economic, social, and environmental spheres. So it has become more encompassing and it has crossed a lot of disciplines already. I mean, the definition of industrial design. So if you're an industrial designer, you're not just sketching and making 3D models anymore. You're also tasked in solving what you call real world problems. No? The challenge is how are you going to make that product solve a real world problem? It has become more than just an extension of, next slide please. I mean, products have become more than just tools or an extension of our arms, but they are becoming more smarter and responsive to our needs. Hindi na lang yung ability to draw and to imagine yung kailangan. You also need to be able to reconcile this with the new technologies, with the new smart technologies that are available. If you notice, products nowadays are becoming more and more smarter. Sometimes they know better than us, no? Especially with cloud-based computing. And that is the direction of of products. No? And if you plan to be an industrial designer in the future, that means you also need to prepare yourself that you will also be able to dabble with these new technologies like software programming. You need to understand what that is, etc., etc. Yung mga ganong side. No? So yun, it has really evolved from what it is back then. No? So kaya then that's why I structured it this way, that I will define it at the latter part of my presentation, because I mean the meaning of industrial back then still holds true. When you design a product, it still needs to conform with the principles of production, because if not, it will become too expensive to produce. No? That's the role of, I mean, that's the at its core, yun yung kailangan at the very basic, no? Kailangan alam mo yung mga yun. But you also need to be more imaginative in terms of ano ba yung mga features na pwede mo mailagay sa isang product, not just the design. Next slide, please. Now, with that, no, with the actually, I think the product development process along, I mean, since the definition of industrial design has evolved, I think the product development process is also evolving, and I think at a much steeper curve, no? Meaning mas mabilis yung progress niya. And one example are the rapid prototyping machines, 3D printers, laser cutters, CNC machines. So they are all enabling you to be able to get into what you call a type of manufacturing that you can do at the comforts of your desktop. No? So desktop manufacturing. No? So here I'm gonna present what I designed before. I designed a furniture, you know, using this process, no? A desktop-based design and manufacturing. No? So ibig sabihin nun, this process is kind of different from the typical yung long process of product development. So I started with an idea, so the concept, no, at the ideation phase. No, I wanted to improve the experience of setting up or assembling yung mga flat pack furniture. No. I wanted to improve the experience by eliminating the small hardware and the use of hand tools to make it. So I wanted to make something that doesn't require these things. No? Kumbaga self-assembly na siya. Next slide, please. So I did not include my sketches here. Hindi ko na siya makita. But from the sketches I made, I did these things digitally. So I made a 3D model on the software. Actually, I used Autodesk to make the 3D model. And then I opened it on SketchUp so I can take a screenshot of it and show it to you. I had a digital prototype in a sense. No? I had a 3D prototype, and I studied the way the parts will interact with each other. Kasi when you do the designs on the 3D software, you can already input the measurements para exact siya. So after doing the 3D design and carefully studying each part and the architecture of everything. I went, next slide, please. I went straight to rapid prototyping. So I used a CNC machine to cut the parts of a plywood. Next slide, please. So this is the first prototype I made. It's made of a different, it's made of MDF. It's a type of board material na cheaper siya than plywood. No? So I made my first prototype. I wanted to see if it will really work. I mean, if it will really assemble. Next slide, please. And then I organized an exhibit. No, I put all the pieces of furniture there because I wanted to gain insights. No, I wanted to get the comments of people, and one of the fastest ways to do that is by exhibiting your work. I mean, inviting people and just letting them try it. Yes, next slide, please. So after getting their insights and finalizing everything, I iterated the design and I used a different material. This time I used actual plywood for the furniture. And this is the final product. No? So with this, I actually accelerated the process. I from ideation to designing, everything was done digitally. That's why it's called digital design. And somehow it's similar to just printing your idea. So I just literally I printed my 3D design through a CNC machine and then assembled everything. So I mean, I just wanted to show you this so that I mean, I want you to try this yourself. You have access to 3D printers, to CNC machines. Studying what software to use is easy. Yes, Tinkercad is a good software to make designs, along with Autodesk. You can use, what I recommend is that you study Autodesk Fusion 360 because it's a complete package. I hope that answers your question. But yes, that actually ends my presentation. I think lagpas na ako dun sa time. But thank you so much for listening. I hope you learned something about, you learned something today. You picked up something. I hope I didn't talk too much. But yes, thank you for listening. That's I think so far that's all I can say. If you have questions, you can ask me. Thank you.
No? Thank you, sir, for giving your valuable insights on understanding how products are developed, the role of science and technology in industrial design. To award the certificate of recognition, may I call on Sir Richard Diseño, our technology unit head. Over to you, sir. Okay, scholars, kindly prepare your questions later.
Okay, so meron na Sir Kurds. Okay, so maraming salamat Sir dito at pinagbigyan mo kami sa aming imbitasyon sa iyo para mag-talk ngayon dito sa Day with the Scientist natin. Finally, naging speaker na namin po kayo. Sana last year pa ito eh. So maraming salamat at maraming natutunan yung mga grade 7 at saka grade 8 scholars natin dito sa PSHS-IRC. Okay, so
Thank you, Sir
bago Yes, sir. May mga simpleng katanungan pa po na tayo dito na sasagutin, sir. So open forum muna tayo bago yung sa certificate. Di ba, Sir Ferds? Okay. So may question tayo dito from our students. Sa clarification, sir, the market pool has demand and need for product direction.
Yes, for market pool, the market dictates what they want, parang ganun. And then the product development team will somehow just change or revise the product to fit that market, parang ganun. So
Okay.
the kumbaga, the percentage of innovation compared to technology push is not that big, but there is still innovation.
Okay, so another question, sir. In average, how long does it take to create the final masterpiece depending on the complexity of the design or the size po? Tanong po ito ni Isabella Gamayo ng grade 7. Ulitin ko po yung question, sir. In average, how long does it take to create the final masterpiece depending on the complexity of the design or the size po?
Okay, just to siguro just for comparison, yung mga airplanes, no, when they start the product development projects of that, it typically takes them at least 3 years, 3 years to complete one. For example, for furniture projects, which is kind of a low technology product as compared to the airplanes, it can take as fast as 3 months to make one. For yung mga handheld devices, napakabilis na ngayon. It probably takes them less than a year to develop a new smartphone or a new tablet. The name of the game nowadays is that they are looking for ways to accelerate the product development process. The reason for this is that if you're a company, you don't want to be late in the game. Somehow you always want to be ahead of the curve. Parang yung term doon. No? You don't want to be behind the curve.
Okay, so I think wala na tayong ibang questions. So I think we have to proceed now to the awarding of certificate. Click ko yung share screen. You're in the show, sabi niyo. Uploads. Hindi makapag-share yung screen ko. Screen mo, sir? Share. Okay na? Click ko yung share. Click ko, sir. Come. Okay, let us now award this certificate of appreciation to our speaker for today. Allow me to read the citation. Republic of the Philippines, Department of Science and Technology, Philippine Science High School, Ilocos Region Campus. This certificate of appreciation is awarded to Professor Fortunato Dela Peña Jr. for his invaluable service rendered as the resource person of the Philippine Science High School, Ilocos Region Campus online, A Day with Scientists, conducted on February 26, 2021, signed Dr. Ronally Orteza, Director 3, Campus Director. Sir, your certificate.
Thank you. Thank you so
We
much.
will send this to you later. Okay? Maraming salamat, Sir Tito,
Thank you
again
so
sa
much for
inyong
inviting me here, sir.
yes, sir. Hoping that the next time, again, pagbigyan mo ulit kami, lalo na kapag wala na po itong pandemya, and babalikan po namin kayo at sana po ay makapunta ka rin dito po sa aming campus. Maraming
Yes.
salamat, sir.
Thank you, Sir Bis. Thank you, Sir Mark. Thank you, Dr. Thank you, Dr. Orteza and Engineer Perillo.
Salamat din kay Engineer Jan Timanguba sa pagiging administrator natin ngayon sa pag-share ng YouTube broadcast natin ngayon. Thank you, Sir Jan. Okay.
Finally, may we have Sofia Carinas, graduate scholar, to give a synthesis and closing remarks.
It has been a great privilege to listen and learn from such an amazing and erudite speaker as Professor Dela Peña Jr. Thank you, sir, for sharing your expertise in the field of industrial design and technology with us today. I am sure that your talk has inspired every one of us. To our campus director and teachers who made this event possible, our sincere gratitude is also extended that despite this pandemic, you still made sure that we get to experience such a fruitful day with a scientist. Thank you everyone for listening and staying tuned in this webinar.
Okay, thank you, Sophia. We have come to the end of our webinar. I would like to thank everyone who made this meeting possible, and I thank Sir Fortunato de la Peña Jr. for his presentation. Thank you all once again for coming.